Hello everyone. Today we are going to learn how a sinusoidal EMF is induced in generator. So let's begin the topic. To understand this thing, first let's clear this basic concept. Just imagine that we are having a magnetic field which is as per shown in display. Now let's assume a conductor is placed in this magnetic field. If we give upward motion to this conductor, what will happen? This conductor will move upward, but you can see from the diagram, from the display, that there is no change of flux occurs with this conductor, and hence there is no induced EMF in this conductor. So we can say that when conductor is moving parallel to the magnetic lines of force, there is no induced EMF in it. Now let's assume another conductor. When we move this conductor horizontally, the change of flux is maximum. You can see from this display. And when this change of flux is maximum, the induced EMF in this conductor will be maximum. And this is the place for no induced EMF when the conductor is moving parallel to the magnetic lines of force. And this is the condition for maximum induced EMF when the conductor moves exactly perpendicular to the magnetic lines of force. We will use this concept to understand how sinusoidal waveform is produced in generator. Here we have two pole, N pole and S pole. When we have two pole N and S, there is a magnetic field from N towards S. So in this magnetic field we will place a conductor, and on right hand side here we will observe the waveform of induced EMF. Let's place a conductor. Before giving shift or giving motion to this conductor, let's understand that through which equation EMF will be induced in this conductor, and that equation is E is equal to minus N d phi by dt, where minus sign represents the direction of induced EMF and N represents the number of turn. d phi by dt is rate of change of flux with respect to time. Now we have single conductor, so N is equal to 1, and we ignore this minus sign for time being, so our modified equation looks like this. E is equal to d phi by dt, which clearly indicates that induced EMF is directly proportional to the rate of change of flux, or induced EMF is equal to rate of change of flux. So now at position number 1, this is the position number 1. So at position number 1, the velocity of conductor is parallel to the magnetic lines of force, like this. So when it is parallel to magnetic lines of force, there will not be any cutting of flux. And when the change of flux is minimum, because at this position the change of flux is minimum, and when the change of flux is minimum, the induced EMF in this conductor is minimum, and that we can see from here. Now we will move this conductor. When we move this conductor, it shifts from position number 1 to position number 2. At position number 2, its velocity is perpendicular to magnetic lines of force. The velocity of conductor is in this direction and magnetic lines of force is in this direction. So the velocity is perpendicular to magnetic lines of force, and hence there is maximum change of flux occur at this position. And because of maximum change of flux occur, we can observe there is maximum induced EMF in this conductor at this position. If we shift this conductor further, you can observe that again the velocity of conductor is parallel to the magnetic lines of force, and hence there is no cut of flux or change of flux, and there is no induced EMF in this conductor when again conductor is aligned horizontally. So this is how we can observe a first positive half of output EMF or induced EMF. Now if we shift this conductor further, let's observe what happens. When this conductor shifted, again its velocity will become perpendicular to magnetic lines of force. And when it is perpendicular, the EMF induced we are getting is again maximum. But what is the difference at induced EMF at 270 degree and induced EMF at 90 degree? The difference between these two is the position of this conductor. The position of this conductor is shifted 180 degree. Initially this yellow portion is towards S side and this black portion is towards N side. And now the yellow portion is towards N side and the black is towards S side. So the induced EMF in this conductor also reverses, and that is why we are getting output voltage or induced EMF in output side. If we shift this conductor further, we can get the further remaining output voltage, and in this position again the velocity of conductor is parallel to magnetic lines of force, and hence no induced EMF. So this is how in complete revolution of conductor we get complete 360 degree or complete sinusoidal waveform in output voltage. Just observe this thing again. This is how conductor keeps on rotating and output voltage keeps on inducing. So this is how EMF induces, a sinusoidal EMF induces in a generator. If you want to know what is relation between mechanical degree and electrical degree, then we have separate video for that, and if you want to watch that video, in description link below I am providing the link for that video. If you have any doubts, if you have any query, then you can ask that doubt and query in comment section. And if you like our work, our video, then please like, share and subscribe to our channel Learning Vibes.